I will communicate with them.
See if we can do something. Yeah, okay. Oh, recording started. That probably means we're about to get underway. Alrighty. Hi, folks. I'm John Grundy from Monash University in Australia. Welcome along to this session on synthesis and performance at ICSE 2022. We're currently just trying to get one of our final speakers into the actual room, so hopefully we'll manage to achieve that in the next few minutes or so. We've got three presentations for you, and they're 5 minutes each. We'll do one after the other. If you have any questions, please pop them into the chat, and then we'll do all the question and answering together at the end after the three short presentations. All right, so the order in the mid-space is slightly different to on the researcher.org. We'll use the researcher.org order, so we'll have a talk from Myung Ju on device API stream pipelines. We'll hopefully get Mukul into the room. We're battling away with that at the moment. Talk about Sapien ML, and then Jin Yu will go third, talk about detecting performance bugs. So let's get started then for Myung Ju from Samsung Electronics. This is going to be telling us about among device AI, and hand it over to you for 5 minutes now, Myung Ju.
All right, thank you. I'm Myung Ju from Samsung, and pardon me for having sore throat and voice. I just got COVID-19 yesterday. Yeah, let's talk about why do we need on-device or among-device AI instead of server-based or cloud-based AI systems. As we are releasing a lot of different consumer electronic devices, including mobile or wearable or TVs and other appliances, data protection and privacy matters. The data we use is from the user contacting devices, and it may have some private data or privacy or data that should be protected. And we don't want to send such data to servers. And then we have latency issues when we have data as a video stream from mobile phones or other devices. And the last part is sometimes this is the most important factor, that we don't have just million devices. We may have over 1 billion devices actively used daily, and we don't want to pay the cloud service cost for that many kind of devices. And in the previous paper of the last year, we have introduced the on-device AI pipeline framework for neural networks. In this pipeline framework, neural network itself is not a pipeline. It is regarded as an atomic filter in a pipeline, so that we can embed multiple different independently developed neural networks into a pipeline. And we can have multiple different data sources, sensors, or preprocessors, or all the other different functions and code into a pipeline. And we have deployed this pipeline framework for different, almost more than several hundred billions of devices in Samsung. And now, as an open source software, we have other users like NXP, Finders, or Cleon, and we have more companies who are trying to use this framework for their products. So why do we need among-device AI, or what we are going to use it for, what kind of products? Here is an example which is already deployed to automotive factory. We have supplied NStreamer as an among-device AI framework for the automotive factory last year and this year. And in this system, there's a camera and mobile device and a wearable device. With camera and mobile device, we can identify the kind of task the user or worker is going to do. And then the mobile device can send order to the wearable device to gather some movement data, including the movements of wrist or vibration or sound. And then it monitors the activity and send back the data to mobile, so that the mobile device can do the inference to check if the recent task was completed correctly or incorrectly. If the recent task was done incorrectly, we can notify via the wearable device that the listen task should be read on. So the whole process can be described in a few pipelines, and we can code that into an streamer pipeline easily. In this actual product, the pipeline description was written in less than 20 lines of code, and it was more efficient and it was more maintainable than the previous systems. And this Among Device AI system is not just for factory workers. We want to expand its usage to the whole home appliances. In houses, we may have different devices, including TVs, mobile phones, and washers, ovens. We want to provide consistent quality of AI service for all the devices, and we want to keep the consistent context across all the devices. And besides that, we want to provide such capabilities to all the other third-party devices as well, because we cannot expect that users will buy only Samsung product. We can expect that they are going to buy products from other companies as well. And let's go to the final slide. We expect that the third parties or other companies may use our software framework because it is open source, and we have already transferred all the rights to the Linux Foundation. So Samsung does not own this project anymore. And you can join us at GitHub. And we already have contributors from different companies already. And we have a lot of different hobbyists as well. So we want to invite you to join us and try to make some better on-device and among-device AI software framework. Okay, thank you.
Great, thank you for that, Myung-Ju. Again, any questions in the chat would be great. As far as I can tell, we still haven't managed to connect Mukul. He's online but can't seem to join the room. I've got no idea why. So we're going to go on to Jin Yu for the moment. Sorry about the jumping around. And if you can give your 5-minute talk,
Sure.
hopefully the background team can resolve things in time for us. Thanks, Jin Yu.
Hello, my name is Xinyu Liu. I'm a student from Georgia Tech. I'm presenting automatic detection of performance bugs in database systems using equivalent queries. This is a joint work with Qi Zhou, who now works at Meta, Joy Aruraj, and Alessandro Orso, who are my advisors. The motivation behind this work is that it is important to have suitable testing techniques for both DBMS correctness and performance. However, most recent research only focused on testing DBMS correctness. The same scrutiny has now been applied to DBMS performance. Performance bugs are missed observations in DBMS that cause delayed response time. For example, a query Q1 to the DBMS, and it takes 13 seconds to finish. Looking at Q1, you can see that the limit 1 keyword only asks the DBMS to return the first defined tuple. So the query should be much faster. In fact, the delay is caused by a performance bug that makes the DBMS ignore the limit keyword. In general, performance bugs can cause significant delay in the DBMS response time and can dramatically affect the user experience. However, detecting such a performance bug is very challenging because there is no general way to defining the expected completion time for a query. To address this challenge, we propose Amoeba, an approach based on differential testing. We construct semantically equivalent query pairs, run each pair on the same DBMS, and compare their execution time. If the time difference is significant, that indicates a potential performance bug. Amoeba has 3 main components: generator, mutator, and validator. Generator is responsible for generating base queries from scratch. Those generated base queries will be used as seed queries for query mutation. Mutator is responsible for mutating base queries while preserving their semantics. The validator compares the execution time of equivalent queries on the same DBMS and reports a possible performance bug if their time difference is above a given threshold. Lastly, the generated bug report consists of equivalent queries and their execution plans. Lastly, Amoeba also includes a feedback mechanism that allows for exploring query spaces that are more likely to discover performance bugs. In our evaluation, we applied Amoeba to T2 DBMS, CockroachDB, and PostgreSQL, and investigate a number of research questions. In this short talk, we only focus on the part of the evaluation aimed at assessing the effectiveness of Amoeba in detecting performance bugs. This table summarizes the total number of potential performance bugs Amoeba discovered and a breakdown of those numbers in terms of developers' feedback. The key takeaway from the table is that Amoeba can detect 39 potential performance bugs. Among those bugs, 6 plus 1 have been confirmed and fixed. The plus 1 in parentheses is a bug report that was not officially acknowledged but matches a planned fix. The table also shows that Amoeba generated 1 false positive for each DBMS, and that 4 of the PostgreSQL bug reports were classified as missing optimizations instead of bugs. The remaining reports for CockroachDB were backlogged, whereas the PostgreSQL developers asked us to post them together on their wiki page, which we are in the process of doing it. Overall, we believe that these results show that Amoeba is a useful tool that can automatically report to developers potential performance issues that may need consideration and assist developers in analyzing the root causes of the reported issues. To conclude, performance bugs can cause significant delays in DBMS responses and dramatically affect the user experience. Amoeba is able to detect such performance bugs by having a feedback-guided equivalent query generation techniques, which allows Amoeba to leverage equivalent queries as differential performance oracles for finding performance bugs. Our evaluation on 2 DBMS is promising, showing that Amoeba can, at least in some cases, detect real performance bugs in widely used DBMS and provide useful information to developers. Thanks.
Great, thanks very much for that presentation, Jingyu. I'm afraid we still haven't managed to resolve the third connecting speaker. Oh no, don't have video available. Oh, great. Okay, well, look, we're going to go on to Q&A for Myungju and Jingyu. If we can get Mukul connected, we'll get him to do his presentation and then take any questions. All right, so there was a question in the chat. I think it's from Myungju to Jingyu. Would it be possible to apply similar approaches to non-SQL databases? Jingyu. You're on mute.
So, yes. So our current technique works only, so we only perform equivalent transformation on the SQL. So in order to test the non-SQL databases, we have to use another set of equivalent, another set of mutation techniques that guarantee to preserve query semantics. But we do believe that the high-level idea of using equivalent queries as differential performance oracles are useful for detecting such performance issues.
Right.
Great.
Thanks.
Thanks for that. Myungju, I wondered, these pipelines, you probably going to have situations where they cross over. So the same device, so a camera, for example, may have 2 pipelines wanting to draw it, say, to recognize something in the environment, and then say draw from it to say do gesture recognition if the engineer is working in an environment that can't access a keyboard or something like that. Have you got a way to resolve those kind of crossovers in pipelines, device contention or memory contention or network contention between the pipelines?
If there are multiple pipelines developed independently and executed independently, that is possible. In mobile phones with Android, it is possible, and we are witnessing such kind of situation quite often. And yeah, as long as the resource cannot be shared, there's no way we can intervene in that situation. But however, for devices that do not accept third-party applications, we can control that. We usually recommend the developers to write a single big pipelines integrating the multiple pipelines that are sharing the same resources.
So I guess the interesting thing there, if you've got kind of a big conglomerated kind of set of things, does that become a maintenance issue, or does that limit reusability, or is that not so far become
Yeah.
a major issue in practice?
It usually limits the reusability, and for that, we are going to provide sort of sub-pipeline libraries that have some shorter pipelines that can be used inside the bigger pipelines.
I got a question here. When communicating between multiple embedded devices with NN Streamer's stream pipeline, how is quality of service between the devices guaranteed?
Well, actually, for inter-device pipelines, we don't have any QoS guaranteed. For networks, we don't provide any QoS capabilities. But for the streams inside the pipeline, we have QoS method there.
Great, thanks for that. Xinyu, I wondered about performance bugs that can't currently be detected. Are there particular problems you can't find, and have you got any thoughts about future work as to how to enhance your approach to be able to tackle different kinds of performance problems?
So I think one future direction is, so currently we do not, we only test the DBMS on a fixed database schema. So it's very simple, only has three main tables. However, in future work, it is possible to run the same queries, but on different versions of databases, like changing the cardinality of the column. So it might be able to catch different performance bugs than our existing ones.
That's great, thanks. I wondered about the data set you've used. So you had a sort of relatively small number of bugs you found, but is that in quite a large number of queries, or is that actually picking up quite a number of quite a high percentage of these issues?
So in our evaluation, we found that when equipped with a feedback mechanism, Amoeba can comfortably run overnight to detect 10 unique performance bugs. And so in theory, we expect to detect more performance bugs if the developers fix those existing bugs.
Great. Any other questions from the audience? I might have missed one. Sorry, we've been trying to diagnose in the chat the connection problems of the third presenter, which we so far appear to have failed to do, I'm afraid. This is obviously I don't know if it's a performance problem or some other problem, but the pipeline is not good for connecting for some of our participants, unfortunately. Okay, another question. When I want to use NN Streamer for communication between edge devices, where can I see related use cases and usage videos?
We don't have usage video yet. We just have XC22 videos for this kind of usages yet. But for related use cases, we have a GitHub page, GitHub repository named NN Streamer examples, and you can get example applications there and see how you can write your own application based on those example applications.
Thanks for that. And then I think there's another question from Wongju to Xinyu. Might be a performance bug and a bottleneck point, such as disk write lock, which cannot be replaced with other methods. How can you discover such a problem?
Can you please elaborate on? So I'm not familiar with the disk write lock issues. So I'm not sure whether Amoeba is able to discover it.
Disk write lock is just an example of a bottleneck point. it appears that Amoeba is, it depends on writing equivalent queries, which is different queries, but with equivalent semantics. But for points like disk write, there's no other equivalent but different point to write, right? So
I see.
yeah, in that case, how can you find it?
Is it a finding problem or a fixing problem, Mungju? I guess one
It's
issue is to find there's a bottleneck, but the second one is to refactor.
Yeah, it's to find the existence of performance bug.
Okay. So Jinyu, perhaps that one's something that either Amoeba doesn't address at the moment, or perhaps it addresses it, but you look at it in a different way. You know, maybe a higher level abstraction of the query formation that results in such a hardware contention issue.
I think so the high level idea of Amoeba is based on differential testing. So in order to detect such disk write log performance bug, we need to find a way to defining a pair of like equivalent input so that we can compare the difference between the two executions given the same input. So I'm sorry, I'm not familiar with this particular system question. So I can only provide a high level idea of Amoeba.
That's no worries. Look, we don't seem to be able to solve the last presenter challenge. There is a long video of their work off the researcher.org page, which I've just sent through, and of course you can contact any of the authors to inquire about that work. Any final questions for Myungju or Xinyu from the audience? Scrolling through again in case I've missed something. Don't think so. I've asked my questions as well, I think. I know one thing, Mungju. So I think you mentioned that it's been open sourced, your platform, and now able to be used by a wide range of other organizations. Is that, did I understand that correctly?
Yeah, we are open to a wide range of organizations, and we already have other organizations working in NSTreamer.
And others are able to contribute to your platform, I presume. So
yeah, they're free to contribute.
Make extensions or otherwise.
Right. They're free to contribute, and they may just fork it out and write their own project based on NSTreamer.
Yeah. Okay. All right. Okay, I don't think we do much else about the final presenter. I'm really sorry about that, folks. So I think we're probably best to finish the session now. And I hope the rest of the sessions will go smoothly today, whatever part of the world you might be in. Thanks very much to Myungju and Jinyu for presenting today. Their papers and other media are available off the conference website as well.
Okay, thanks.
Thanks.